Okay, so significant figures is probably the one thing that students least understand when I teach. The purpose of significant figures is to tell you how accurate a number is that's reported to you. In other words, when somebody measured that number or when they told you what that number is, how close is it to reality? Or how much did they round and how inaccurate is it? So let's take a look at something. Let's suppose somebody went out shopping, right? And they bought some clothes. And you say, okay, how much did you spend that day? And the person says, I spent $100. $100. Now, I don't think anybody hearing this would think that that person went to the store, they handed the cashier exactly a $100 bill, and didn't get any change back. You know, when your friend says that, you know it's probably not exactly $100, right? Maybe they spent $96.43. Or maybe they spent $108.22. But you don't care about all that, right? When you ask your friend how much you spent, they say $100, that's close enough. This is all the information you want to know. It's not a very accurate number because they're rounding, but that's about as much as you care about. And if they bought 2 or 3 things, they're not going to add it up exactly anyway. They're going to add it up in their head and come up with a rough estimate of how much money they spent, and that's good enough. So this is a very inaccurate number. In the terms of significant figures, we would say it has 1 significant figure, whereas something like this has 4 significant figures, a much more accurate number. And this becomes important when we talk about adding numbers, subtracting numbers, multiplying numbers. We don't want to get an answer and say it's more accurate than the inaccurate information we were given. All right, so today what I'm going to do is I'm just going to give you the rules for knowing how many significant figures are in a number, and then tomorrow we'll talk about when we add, subtract, multiply numbers, how many significant figures should be in our answer. So all you need to remember is this is about accuracy, how accurate are numbers, and what these rules are. So rule number 1, all digits 1 through 9, so all non-zeros, are always significant. So for example, I write the number 400. This number has 1 significant digit, only the 4. So 1, I'm going to abbreviate this and call it sig fig. 1 significant figure. On the other hand, if you see a number like 413, these are all non-zeros, that's 3 significant figures. And if somebody says 413 in your mind, you would think that's a much more exact number. They're telling me exactly how much. Versus if somebody said 400, you kind of know that that's kind of an estimate. So more significant figures means a more accurate number. All right, rule number 2. Zeros, and all the rest of the rules deal with zeros. So remember, 1 through 9, always significant. Zeros between, no? All right. Yeah, is that right? No even zeros?
Yeah, so
Okay. It looks like it should be. Zeros between significant figures are always significant. You sure about that, E?
yeah.
All right. All right, so for example, 402. So here we know the 4 and the 2 are significant because they're non-zero numbers. But the zeros between non-zeros, it's between significant digits, so that's also significant. So this has 3 sig figs. On the other hand, if I give you the number 420, 4 and the 2 are significant, but the 0 is not, because it's not between the non-zeros. It's not between significant figures. That only has 2 sig figs. All right, number 3. Trailing zeros that means zeros that are after a non-zero number, to the right of them, are only significant if the number contains a decimal. So, for example, the number 6,000. This number, has everybody got number 2 already? Anybody falling behind here? I'm going to erase number 2. Okay, so for example, 6,000, there's only one significant digit. Right? One significant. It's just 6. The zeros are not. But if I had something like this, let's say I had 6,000.00. When somebody writes a number like this, and they put a 0 after the decimal, this is to tell you that this was measured to the nearest 100th. So it's accurate to that place. So by putting that decimal there, all the zeros now become significant. So this is 6 significant figures. Just to make sense of the number 6 is there.
So if there's only 2 after the decimal, that means this is
If there's any number after the decimal. If I had 10.0, that's significant, and so then these ones are. So that'd be 3.
So it's like 10.01.
Absolutely, yeah. Because then that'd be rule number 2 also. Or number 1 rather. Any non-zero is also significant. So this would be like 4 like that. All right, let's do rule number 4. Zeros. What am I doing here? Zeros in the beginning of a number. The beginning means to the left of any non-zero. Are never significant. So you only see this in numbers that have decimals. Let's say we have 0.0025. So these zeros here, they're there to push that 2 and the 5 over to make this, 25 10,000ths, right? If I didn't have these zeros here, it'd just be the number 25. So these are not to denote accuracy. So they're not significant. Only the 2 and the 5 are. So 2 significant figures. Now trailing zeros are, so if I had 0.00250, these 2 of course are because they're non-zeros, but also that extra 0 to the right is also going to be significant because that's after the non-zeros in a number that contains a decimal. So this has 3 signals. All right, last rule. Numbers. Oh, wait, good, take your time. Questions on 3 and 4 before we go? All right, so number 5, this is the last rule, and this is numbers in scientific notation. So for those, only the coefficients matter. matter. So you're not going to look at the exponent. The number says 10 to the power of 25 below it. That's completely irrelevant. You're just going to look at the first number that's multiplied by the exponent. That number, how many significant figures that has, that's how many is in the answer. So let's say we have 2.50 times 10 to the power of 40. So all we look at is this, just the coefficient. The rest of it doesn't matter. So if you look over here, this number has 1, 2, and that 0 is significant too, because of rule number 3. And so this has 3 sig figs. So it doesn't matter what the exponent is. The exponent's irrelevant. All right, let's do a few examples.
So let's say if it was, let's see, we were doing 3. 0.02. I'll put a 5 after that.
Okay.
Times 10 to the 40th. The only ones that would count was 2, 5.
2 and the 5.
And it'd be 2.
So it would have 2 sig figs. All right, let's do some more. What if we have 600? How many sig figs is that? 1. Right? Now what if I had 600.0? 4. It's going to be all of them, because since this one is after a decimal, it's a 0. So basically, because there's a decimal, anything to the right of the 6 is going to be significant, no matter how many zeros I put there. So it'll be all the numbers. All right, what if we have 0.010? It's just 2, right? It's the 1, and then anything to the right of the 1. All right, what about 0.01011? 4, right? All the non-zeros, and then of course this one. That's 4. All right, what about 6,040?
3.
Yeah, not the last one. So the non-zeros, of course, are significant. And then rule number 2 says any 0 between significant figures is always significant, so that one is. But because there's no decimal, this 0 is not significant. So remember, there has to be a decimal for the zeros to the right to matter. All right, we good with this?
Mm-hmm.
All right. Bobby.